Hey guys, we're back on vectors and we're just going to continue where I last left off. Now, one of the equations you'll have to learn, or you'll have to at least use in the exam, is the following. It's A dot B, which we can see here, I'll go through that in a minute, equals modulus A times modulus B times cos theta, where theta is a random angle. Now, this probably doesn't make too much sense at the moment, but hopefully I'll be able to clarify what it means in just a few minutes. A better way of writing this expression, and a more useful one given the questions that you'll probably see in an exam, would be A dot B divided by modulus A modulus B equals cos theta. And all I've done there is just taken this A dot B, divided through by it, so it ends up on that side. Okay, now A dot B, alright, let's make this obvious. A dot B, as you can see up here, is written as follows. It's A1 B1 plus A2 B2 plus A3 B3. And that is assuming you use these vectors. Vector A equals A1 2 3, vector B equals B1 2 3, and it's basically just taking the sort of I value of each vector, multiplying them, adding the sum or the product, sorry, of the J vectors plus the product of the K vectors. Just to be clear, this A dot B is different to sort of when you use dot as a multiplication, so sort of x dot y, it usually just means x times y, which is a bit different. You gotta just notice that this is the dot product and not just a standard product. It's not a standard multiplication. That's all you really need to know. You don't need to know where it comes from or how to derive it. It's just that, and it's worth knowing. So if I write up the equation we used earlier, or we saw earlier, A dot product B over modulus A modulus B equals cos of an angle, we'll call it alpha this time. What this is basically saying is if you have these two vectors A and vector B, 2 points, then what you can do is you can do the following calculation, and the answer of that will give you cos alpha. Just quickly, if you're not sure, modulus A or modulus B, modulus of a vector, let's use A for an example, is just the size of the vector. So just say the vector is a point, then the modulus will be the size, the length of the line between the origin and this point A. That's all modulus is. It's the magnitude of the vector. And to calculate that, if we use this vector here, A1, A2, A3, then the modulus of that vector would be root A1 squared plus A2 squared plus A3 squared. Pretty simple. And so if we use that along with our dot product and we divide them like so, then we will get cos alpha, where alpha is the angle here between the vector between the vectors A and B, or between the lines A and B. And that's all it is. But what this will help you to do, as well as questions which will say find out the angle between the vectors, pretty simply worded, is it might say find out if these two vectors, and they'll give you two vectors, find out if they're parallel, or find out if they're perpendicular. And So we'll just do that quickly. Perpendicular means that the vectors are at 90 degrees to each other, like so. There's a 90-degree angle. And so if we use that, we can say that cos A, this, equals cos 90, since the angle between them is 90 degrees, they're perpendicular. And as we know, cos 90 equals 0. Cos graph quickly. It's like this. 90 is here. This is 0. So cos 90 equals 0. And what that basically means is, if we bring this left side down to here, it means that A dot B over mod A mod B equals 0. And as we know with any fraction at all, that if the top equals 0, if the numerator equals 0, then the whole fraction equals 0. For example, 1/3 is 1 divided by 3. However, 0/3 is 0. 0 over x is 0. 0 over anything is 0, regardless of what's on the bottom of the fraction. So if we use that knowledge, then we can say that if we want this to equal 0, then all we need to do is make sure the top equals 0, and the top is A dot B. So if I rub this off, then all we need to do is ensure that this dot product here, again, A dot B equals 0. And so you can do the calculation accordingly. I'll just do a really quick example. If we have 1, 2, 3 is our vector A, and our vector B can be 3, 4, 5, then the dot product will be, let's say A dot B equals 1 times 3, which is 3, plus 2 times 4, which is 8, plus 3 times 5, which is 15. And if we add those together, 3 plus 8 is 11, plus 15 is 26. That means that A dot B, the dot product, is 26. So therefore, A dot B, the dot product, does not equal 0. Therefore, the lines are not perpendicular. That is all we need to prove in a question which might say, show that A and B are not perpendicular. What you need to do is find the dot product, as I've done in these two steps, and just state that it does not equal 0, and therefore they're not perpendicular, because like we said, when A dot B equals 0, they are.